So this is the kit that we will be using for Zener diode characterization. In Zener diode we will do the forward and reverse characteristics. That means the characteristics of the diode we will study when it is forward biased as well as when it is reverse biased. This is the Zener diode, and if you see, there is a black mark at one end and there is no black mark in the other end. So this the end where there is a black mark, that is the negative side, and this is the positive side. Okay. So this Zener diode we will connect it here. So this kit have all these whatever connections are shown in black, they are there inside this kit. Whatever is remaining outside, those connections we have to make with the wires. So first, if you see, there is the components that are present here in this circuit. It's a power supply. This is a regulated power supply which goes from 0 to 20 volt. Then there is a resistor. Then there is a voltmeter. This voltmeter's display is shown here. And then there is a milliammeter whose display is here. All these things we have to connect with the Zener diode in this connection. So we'll just start doing the connections. These are the wires. So if you see here, there is no black line here or there. That means this is open. We have to connect this one to make it a closed circuit. So I will connect this to make it closed. Also I will use another one. Yes. Then there is a voltmeter that needs to be connected. This is the display for the voltmeter. So we will connect with the display of the voltmeter. Then there is a milliammeter. Milliammeter's positive will go to the positive of the display, negative will go to the negative. That's all is the connection. And we have put the Zener diode in forward bias condition here. Then we'll switch on this kit, and you can see there are two knobs here. This is for coarse increase and this is for fine tuning. Means when you require very low amount of voltage increase, you have to use this one. If bigger steps you need, you have to use this knob. So in the forward bias condition, first we will take the reading. So in the forward bias condition, as we know, we have to start from 0.1 and then go till 0.5 in steps of 0.1. After 0.5, we will go in steps of 0.05 and see where exactly the current is picking up. Okay. So we will start from the beginning. So we will just make it. So this is the voltage I am giving. So right now, if I give, it's a very, very fine, it takes some time to stabilize. Just give it time to stabilize and see what is the value. Otherwise, you may end up taking some wrong, this one. So 0.09 is almost equal to 0.1. Yeah. So the current is 0 here. If I go to 0.2 or 0.3, you have to take readings for 0.1, 0.2, 0.3, 0.4 like that. I am just going directly to 0.3 and seeing what is the value here. Again 0, then I will go to 0.5. You can see very, very carefully you have to give the voltage, otherwise this is 0.4, still it is 0. I will increase it more. Yeah, 0.5 also 0. I will go till 0.6 I will go, and then after that I will go in steps of 0.2 or maybe 0.55. I will just see once how it is showing. Yes, still it is 0. Go to 6. Still 0. Then I will go to 6 point. Slightly it started increasing. I will go to 6.2. 2, 0.1 is the current, 6.4, 0.2 is the current, or not 6.4, sorry, 0.64, then 0.66, current is 0.4 milliampere, because we have put this switch in milliamperes. There are two scales, one is micro and one is milliampere, so I have put it in milliamperes, so the reading is incoming is in milliamps. Then 0.68, it has gone to around 5.4 or 5.6, then 0.7, I'm leaving it, around 6 only, then 0.72, current is high, 7.7, 0.74, see there is a huge increase in the current, it is 15.3, then 0.76, it's 18.9. So by this time you have gone to the peak of the current, and I think till 8 or 8.2 you can take and plot the graph like this. So this is about the forward biased characteristics. I will reduce the voltage and then I will switch it off to make the connection to reverse bias. So here now what I am doing is I am just putting it in the opposite direction. Yes. Okay. So that then this is the positive side of the battery is connected to the negative side of the diode, and the negative is connected to the positive side of the diode. I will switch it on once again. Here we have to go, we will start from 1 volt, 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, and then till 8 volt, 8 to 10 volt we will go. After 11 we will go in small steps. Yes, so we will use this course, yes, we will use this course tuning, and I will directly go to 1 volt, current is 0, we will go to 3 volt directly. You have to take readings for 2, 3 all. I am just going to 3 just for giving the demo. Still it is 0, I will go to 5, still it is 0, I will go to 7, still it is 0, I will go to 9, still it is 0, I will go to 11. After 11 I will start increasing in small steps. Yes, 11, it is 0. Then I will go to 11.5, because that is where we expect the breakdown to happen. Still it is 0. 11.12 I will go, see at 11.7 only it has started increasing, 1.3 is the current, 1.3 milliampere is the current. Then I will go to 12, 11.9 is 12.3, then 12 I will go, 12 volts, 29.1. So you have to take very small steps from 11 to 12 in steps of 0.02, 0.2 you can take, so that you get a proper curve which shows the breakdown of the Zener diode. Okay, so these are two small experiments that you have to do. Once you have taken all the data for various voltages, you have taken the currents, then you have to plot a graph with the x-axis having the voltage, y-axis having current, plot it for forward and reverse bias condition. Okay. Always before switching off, you have to reduce the voltages to 0 and then switch off the kit. And after switching off the kit, the first thing you have to do is to disconnect all the wires and put them in the respective boxes, so that next time when you do the experiment you can have all the things set up in the box itself. You cannot keep all the connections after doing the experiment. It's a must step. Okay, take all the connections out, put them in the box and switch off the